हेलो बच्चों, हाउ आर यू? आई होप दैट you all are good and doing well in your life and career and preparing for the examination very sincerely, because this video is dedicated to the physics people who are interested in physics and want to learn physics. So we will solve the problems related to the physics and that were asked in the previous examinations like IIT-JEE, mains and advanced. And this video is going to be helpful for other competitive examination at the national level like IIT-JAM, NET-JRF, CSIR and other exams like PGT and assistant professorship for the subject physics. So remain through the entire video so that every concepts and fundamentals which I am going to discuss with you will be clear and may help you. So let's start the video. Myself Virendra Kumar and you are watching here Cosmos. In this video we will solve the problems. That is, a block of mass m is placed on a surface with a vertical cross section given by y is equal to x cube upon 6. If the coefficient of friction is 0.5, the maximum height above the ground at which the block can be placed without slipping is option 1, 2, 3, 4. सो इन दिस वीडियो आपको क्या करना है कि इसको बताना है कि कितने हाइट पर हम ब्लॉक को रखें कि विदाउट स्लिपिंग जो है उसको हम रख सकते हैं, और उस सरफेस का आपको कोफिशिएंट ऑफ फ्रिक्शन दिया हुआ है. सरफेस क्या है? जिसका वर्टिकल क्रॉस सेक्शन जो है आपका y = x³/6 है. ठीक है बच्चों, तो इस तरह के सवाल को अप्रोच करने के लिए आपको क्या लगता है? देखिए, इसमें जो है इसमें पूरा जो फ्रिक्शन का रोल है, फ्रिक्शन से रिलेटेड आपको कंसेप्ट पता होना चाहिए. सेकेंड है कि इसमें जो है मास की बात कर रहा है, मतलब मास m इज गिवन, ए ब्लॉक ऑफ मास m इज गिवन, दैट इज you must have the knowledge of the Newton's laws. So combining these two things we can approach this problem. So let us start here. So the cross section we will draw vertical cross section. So vertical cross section is given by y is equal to x³/6. So if you draw this on the x-axis, you will find this as a curve that is moving like this. You can plot this curve, no problem. So this is x-axis and this is y-axis and this is origin. So if you want to place a block of mass m, you want to place at this surface, right? So that it could not slip, and you have to determine the height. At what height you should place this block? So let us consider that this block is placed at this height. So this block has mass m and its height from the ground is y, right? And if you draw a tangent, so it will touch the ground horizontal surface making angle theta. So this is the diagram associated with this question, and if you are able to draw this diagram, half of the job is done, right? Now you have to find the y, right? So here we will discuss about the limiting friction. So limiting friction क्या होता है? What is limiting friction? Limiting friction is the maximum value for the static friction. Why static friction? Because we want to place the block in the rest at the surface, and in such a way that it could not slip. And in that situation, what is keeping the block, what is preventing the block from slipping? That is only the friction acting between the block and the surface, right? And surface coefficient of friction is mu is equal to 0.5. It is given, right? So static friction is here, and if the block is try to move down, the maximum static friction that can hold the block is the limiting friction, right? Beyond this, if you apply the force beyond this friction, the mass will slip or mass will start moving. So what the forces acting here, you must, so forces acting here is the mass mg, down in the downward direction mg, right? And if you resolve this into two components, so this will be 90 minus theta, and this will be mg cos theta, and this will be mg sin theta acting along the surface. So this is the force due to this mass acting along the surface in the downward direction, and there is a normal reaction, that is n, which is equal to mg cos theta, right? So we want to discuss here the, in the limiting friction case, our frictional force F is equal to mu n, and this mu n is equal to mg, this F is equal to mu mg cos theta, and mu is given 0.5, right? 0.5. And this is the frictional force acting opposite to the mg sin theta, and in the limiting friction case, this friction F must be greater than or equal to the mg sin theta. So in limiting friction case, in limiting friction, mg sin theta should be less than equal to this friction, that is F is equal to 0.5 mg cos theta. after simplification we see that mg is on both sides, that is sin theta less than 0.5 cos theta, right? That means we see that tan theta should be less than equal to 0.5, right? So this is the value for tan theta, and when the block is in the static position, then that equality comes into account. Then in the static position, tan theta is equal to 0.5. Now we will find this tan theta in terms of dy by dx. That is, tan theta is nothing but the slope, and we can find the slope from the equation y is equal to x cube upon 6 also. So let us find this. Y is equal to x cube upon 6. Therefore dy upon dx is equal to 3x square upon 6, that is x square upon 2, and this is nothing but the tan theta. Tan theta is equal to x square upon 2, and from the previously we know that tan theta is equal to 0.5. 0.5 is equal to x square upon 2. This gives x square is equal to 1.0. Therefore x has two values, plus minus 1. So for y to be positive, we take the x positive, because if you place the x negative value in this, y will be negative. The height should not be negative. Therefore we take x is equal to 1. Therefore y is equal to x cube upon 6, that is equal to 1 upon 6. So y is equal to 1 upon 6. So this is the height of the block at which if we keep this block, then the frictional force will be sufficient to stop this from slipping down, right? So the option is given in the, this is 1 upon 6 meter. So 1 upon 6 meter is the height, should be the height of the maximum height that you should get, right? Now the point maximum you can also decide from this fact also, because we have taken the equal sign. If you keep this inequality, then tan theta should be less than equal to 0.5, and here it will be according to the situation, and you will get the maximum height. Matlab less than equal to 1 upon 6. This will be the maximum height, that is 1 upon 6. So bachcho, I hope that you get this solution and it is useful for you. If you like this video, press the like button and share this with your friends and family members, so that others can also learn about this problem solving techniques. So let's meet in the next video. Thank you.